In this demonstration, I'll show you how to determine the pH of a solution when given the hydrogen concentration. In chemistry, we encounter logarithms when dealing with the measurement of acidity of an aqueous solution. pH is defined as the negative log of the concentration of hydronium ions represented as H+. You will need to know the following and keep in mind the relationship between logarithms and exponents, and that's shown right there. Question number 1 reads, determine the pH of a solution that has a hydronium concentration of 7.40 times 10 to the power of negative 3 molars. What we will do in this situation is use the following formula, the one shown here, where pH is equal to the negative log, the concentration of H+. Next, we will substitute this value, and this M represents molar, so it's the concentration. We're going to substitute this number into here, and we end up with pH is equal to negative log. And now, since a base is not shown here, we are going to assume that it's base 10, 7.40 times 10 to the power of negative 3. You should also keep in mind significant figures for these types of examples. So this right here has 3 significant figures. I'm going to write that in, 3SF. And so we're going to use our calculator now. Negative log 7.40 times 10 to the power of negative 3. And we get 2.3 as our pH. And this is in the correct number of significant figures, and that's the answer for question number 1. In the next question, they're asking us to convert 3.5 times 10 to the power of negative 3 H+ to pH. Now this is the exact same question as before, just written differently. And once again, we're going to say pH is equal to negative log of that number, 3.5, this time 3 significant figures. And placing this into our calculator, we end up with negative log 3.5 times 10 to the power of negative 3. And we end up with 2.455. Now, since this number is followed by 5, therefore this number will go up to 2.5 as your pH, and that's the answer. Moving on to the last example, what value of H+ corresponds to a pH of 4.3? So this time we're going to have to work backwards. We're going to use the same formula where we have pH is equal to negative log base 10 of H+ concentration. And now our pH is 4.3. So we have 4.3 is equal to negative log of the concentration of H+. Now, of course, we're not writing this 10 because we don't need to. It's assumed that it's already base 10. We're going to need to get rid of this negative first. We're going to divide both sides by negative, and we end up with negative 4.3 log of the concentration of H+. And now we can actually use this formula, this variant of the formula. But just to give you an understanding as to how that was derived, keep in mind that you can get rid of a log. You can solve for this if you set both of these numbers to powers of base 10. So this would cancel out the log, and that's where this version of the formula is derived from. We're going to use our calculator. 10 to the power of negative 4.3 gives us a concentration of 5.01 times 10 to the power of negative 5. Now, keeping in mind significant figures, our final answer will be 5.0 times 10 to the power of negative 5 molars. And there you have it. 3 examples on how to determine the pH of a solution when given the hydrogen concentration. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, visit our website at studyforce.com. We're an online service for students seeking free homework help. See you soon.